In section 1.4, we are discussing complex numbers. Don't forget to go over the supplemental notes posted in Canvas for any examples I may have skipped in this video. Let's begin by talking about the imaginary unit, which is the letter I, and it is defined as I equals the square root of -1, where I squared is equal to -1. For example, if I have the square root of -25, that is equal to 5i. When we write our numbers, we are going to have a real part and an imaginary part that we write a plus bi. When we add and subtract complex numbers, we use like terms. So for example, if I have 2 plus 3i minus i plus 5, we are going to add the 2 and the 5 together, and then we'll add the 3i and the -1i together. Putting that all together, we get 7 plus 2i. When we multiply complex numbers, we're going to multiply using normal multiplication rules, and then anytime we see I squared, we're going to replace it with a -1 and then simplify. Let's take a look at this example. 2i minus 1 times 3i plus 5. I have a polynomial times another polynomial, and so we are going to FOIL like normal. So 2i times 3i is 6i squared, 2i times 5 is 10i, -1 times 3i is -3i, and -1 times 5 is -5. Then I'm going to replace I squared right here with -1, and I'm going to combine my like terms in the middle. So it's going to say 6 times -1 plus 7i minus 5. Next, I'm going to compute the multiplication, so that's -6 plus 7i minus 5, and then combine my like terms, -6 minus 5, -11 plus 7i is my solution. Next, let's talk about complex conjugates, just like we did when we talked about square roots in a previous section. So, if I have a plus bi, its conjugate is a minus bi. If I have a minus bi, its conjugate is a plus bi. So the conjugate tells me I should flip the sign in the middle. Let's look at an example of this. I want to rewrite 2i divided by 3 minus I, so I'm in the form a plus bi, meaning I don't want to have any i's in the denominator of a fraction. So to remove the I, just like I did with square roots, I'm going to multiply by the conjugate. In this case, my conjugate is 3 plus I. Remember, in math, whatever I do to the bottom of a fraction, I have to do to the top. So on top here, I'm going to have to distribute. I'm going to get 6i plus 2i squared, all divided by, and on the bottom, I'm going to need to FOIL. So I'm going to have 9 plus 3i minus 3i minus I squared. Next, I'm going to gather any like terms I can, and remember, replace I squared with -1. So on top, I have 6i plus 2 times -1, all divided by 9. And then I see my 3i and minus 3i are going to cancel out. Then I have minus I squared, and so I squared, replace it with -1. So I like to write out all my steps so I don't mess up any signs right here. So please be careful of that. Use some parentheses. Alright, and so what does this simplify to? I have 6i minus 2 all over 9 minus -1, so negative becomes positive there. And so that equals 6i minus 2 all over 10. Although the problem is done, I notice everything is divisible by 2, so I could go ahead and reduce this. This is going to reduce to 3i minus 1 all over 5. And that is complete. Last example, let's look at a square root problem. All right, I have square root -18 minus square root -8. Remember in math, in order to subtract square roots, they have to have the exact same thing underneath the square root symbol. In this case, they are not alike, so let's see if we can simplify first before we subtract. So let's do a tree on 18. So that's 2 and 9, 3 and 3. I have a pair of 3's with the 2 left over. So that is going to give me 3 comes out, 2 stays in, but I also noticed I had a negative underneath the square root, so that means I have an imaginary number, so an I is going to come out. So the square root of -18 is equivalent to 3i square root 2. Let's repeat with 8. 2 and 4, 2 and 2. I have a pair of 2's with the 2 left over, and I have a negative, so that is going to become 2i root 2. And remember, I'm subtracting, so minus sign there. And now I have I square root 2 and I square root 2. So those two guys, this guy and this guy, are now exactly the same. So I can subtract the leading coefficients. 3 minus 2 is 1. So you can write the 1 or leave off the 1. Either way is fine. So you can write 1i square root 2, or you can just write this as I root 2. And that is your solution.